Ready.
Okay, done. Good morning, students. Today I will start BSc first semester. BSc first semester, the inorganic chemistry, the chapter coordination chemistry. The coordination chemistry. So the syllabus when our college belongs to, that is Vijayanagara Sri Krishna Devaraya University, Bellary. Under that we will come across, that is GBR College, Huvinadagi. GBR College, Huvinadagi. So what is coordination chemistry? The coordination chemistry means they are made up of, the compounds are made up of what is called as coordination compounds. The coordination compounds means, so the first is, the chapter heading is coordination chemistry. Coordination chemistry. So what is coordination chemistry? The coordination chemistry means the compounds will be having the coordination, the bond with the central metal ion in a square bracket will be called as a coordination compounds. So the coordination compounds, like if we have CuNH3 the 4 times the SO4, this is called as a coordination compound. This is an example of a coordination compound. So this is called as cuproammonium sulfate. This is called as cuproammonium sulfate. Then we will be having the second compound is what is called as K3FeCN6. This is called as potassium ferricyanide. This is called as a potassium ferricyanide. Then we will be having the compound like what is called as K4FeCN6. This is called as potassium ferrocyanide. This compound will be called as a potassium ferrocyanide. Potassium ferrocyanide, and this is called as a potassium ferricyanide. Potassium ferricyanide. So potassium ferricyanide. So these are all some examples of what is called as coordination compounds. CuNH3 4 times, SO4, that is cuproammonium sulfate. The second one is potassium ferrocyanide, K4FeCN6, and the K3FeCN6 will be called as potassium ferricyanide. So the some more examples of what is called as the coordination compounds are like so in these compounds will be called as, the copper will be called as central metal ion, and ammonia will be called as a ligands, and in this structure the iron will be called as a central metal ion, and the cyanide will be called as a ligands. In the same way, in this structure potassium, the ferricyanide, the iron will be called as a central metal ion, and the cyanide will be called as a ligands, and cyanide will be called as a ligands. Suppose we will write the structure of the cuproammonium sulfate. We will write the structure of what is called as a cuproammonium sulfate. So this structure will be like this is the central metal ion is Cu plus 2 is there. The first one will be called as ligands, the NH3. The second ligand is NH3, and third ligand is the NH3, and the fourth ligand is NH3. So this is called as the structure of what is called as cuproammonium sulfate. The cuproammonium sulfate. So in this structure, all the 4 molecules of ammonia, that is one ammonia molecule, second ammonia molecule, third ammonia molecule, and the fourth ammonia molecule. So they will be called as ligands. They will be called as ligands. The ammonia molecule will be called as ligands. Like for example, the ligands is ammonia, the water, chloride, bromide. Then we will be having the iodide. All these examples will be called as that is a ligands. So these ligands they can donate a pair of electrons to the central metal ion. So suppose for example, if we take this ammonia molecules can supply a pair of electrons to the central metal ion, and this ammonia molecule supplies a pair of electrons to the central metal ion. And this ligand can supply a pair of electrons to the central metal ion, and this the ligand ammonia can supply a pair of electrons to the central metal ion through a coordination of bond. Through a coordination bond. So this is called as the first coordination bond. This is called a second coordination bond. This is third coordination bond, and this is a fourth coordination bond. So these coordination of the compounds will be having the coordinate, the bond is entirely different from what is called as a covalent bond and ionic bond. The ionic bond, the molecules are they are highly soluble in water, whereas the covalent compounds are highly soluble in organic solvents. They are soluble in the highly soluble in organic solvents. But these coordination, the compounds or special compounds, they will be having the coordinate bond. So these coordinate bond, they can supply a pair of electrons to the central metal ion. They can supply a pair of electrons to the central metal ion. So this is the first example of what is called as ammonium sulfate. Then we will be taking the second compound. Then we will be taking a second compound, what is called as potassium ferrocyanide, K4FeCN6. K4 the FeCN6. So this K4FeCN6. Thus in this compound, the central metal ion is the iron Fe+2 is there. This is the first ligand cyanide, and this is the second ligand of cyanide. This is the third ligand of cyanide, and this is the fourth ligand of cyanide, and this is the fifth ligand of cyanide ion, and this is the sixth ligand of what is called as the cyanide, the CN. So all these ligands can donate a pair of electrons to the central metal ion through a coordination bond. Through a coordination bond means this can suppress a pair of electrons, and this cyanide will suppress a pair of electrons, and this cyanide will suppress a pair of electrons, and this cyanide suppress a pair of electrons, and this cyanide suppress a pair of electrons, and this the cyanide suppress a pair of electrons to the central metal ion, to the central metal ion. In the same way, all the d block elements, that is either if you take a copper or the nickel or the cobalt or the iron, or you will be having platinum or palladium, all these compounds, they forms what is called as a coordination compounds. They forms a coordination compounds. The coordination compounds means, like for example, if you take a chloride or the bromide or the ammonia, or you will be having carbon monoxide, or you will be having water molecule, all these compounds will be access the ligands. They will be access the ligands. Suppose for example, if you take another compound like what is called as the platinum, so we will be having the next compound is PTMS3 the 6 times, and the charge is +2. So this is called as hexamino platinum. Hexamino platinum is. So in this structure, the platinum is a central metal ion, and it will be having the first ligand is NS3, and second ligand is NS3, and the third ligand is NS3, and the fourth ligand is the NS3, and the fifth ligand is NS3, and the last one is fifth and sixth ligand of ammonia molecule. The ammonia molecule. In this structure is also the same. This ammonia molecule is the ligand. It supplies a pair of electrons to the central metal ion of the platinum, and this ligand can donate a pair of electrons to the central metal ion, and this ligand can donate a pair of electrons to the central metal ion through a coordination the bond. In the same way, so these and this that is called, they can supply a pair of electrons to the central metal ion. So like this, the platinum, the compound is also the supplies the ligands of platinum will be supplies a pair of electrons to the central metal ion of the platinum. So in the same way, if you take the compounds like some more examples of what is called as the coordination compounds. So the coordination compounds like what is called as NiCO4 times nickel tetracarbonyl. This is called as another what is called as the example of coordination the compounds. So in this example, the nickel tetracarbonyl, so that is what is called as the cobalt. The carbonyl group will be called as ligands. They will be called as ligands. So here actually what happens, the Ni+2 gives rise to, this is the first ligand, and this is a second ligand, and this is the third ligand, and this is what is called as the fourth ligand of what is called as the carbonyl compounds. So this ligand of the carbonyl supplies a pair of electrons to the central metal ion, and this ligand can donate a pair of electrons to the central metal ion, and the third ligand of carbonyl supplies a pair of electron, and the fourth ligand of carbonyl compound supplies a pair of electron to the central metal ion. So this is called the next example of what is called as a coordination the compounds. So the coordination compounds will be having that is coordination the sphere, then we will be having coordination number, central metal ion, the ligands, all these will be called as contains for every that is a coordination the compound, they will be associated with what is called as a coordination number, the coordination the sphere, central metal ion, ligands, all these compounds will be called as that is a coordination the compounds will be contains, that is ligands. So the ligands means they can donate a pair of electrons to the central metal ion. They can donate the electrons, pair of electrons to the central metal ions. So in the same way, if you take it the compounds like what is called as carbonyl compounds or the nickel compounds, or will be having what is called as platinum, the palladium. So all these compounds will be having that is coordination compounds. So these are coordination the compounds. They will be having. Suppose if I read another compound, so that is PTNS3, the 5 times Cl. So this is also called as another what is called as coordination the compound is. So that's the PT, this is NS3, and this is NS3, and this is NS3, and this is this is the NS3. So this is NS3. So like this, they will write it what is called as this coordination the compounds. This is the coordination the compound. So all these compounds will be called as that is coordination compounds. So these are the coordination compounds will be like this. Then we will come across what is called as the classification of ligands. So first of all, what are the ligands? The ligands means they can donate a pair of electrons. They can donate a pair of electrons to the central metal ion. A central metal ion, for example, if you take cupro-ammonium sulfate, or will be having cobalt compound, or the nickel compound, or the platinum, or the palladium, or the silver, whatever it may be, sir. So all these compounds will be called as the central metal ions, and the ligands like what is called as a chloride is a one ligand, the bromide is a ligand, the carbon is a ligand, the water is a ligand, the ammonia will be called as a ligand, then the oxalate ion COO minus a single bond COO minus will be called as oxalate ions. So all these the compounds will be called as ligands. So these ligands they can classify into that is the four types. The first one is monodentate ligands, second one is bidentate ligands, third one is tridentate ligands, the next is tetradentate ligands, and finally the polydentate ligands as well as. So that is ligands can be classified into the different types. The first one is monodentate ligands, second one is bidentate ligands, the third one is tridentate ligands, and the next is polydentate ligands, and last one is chelating ligands. The last one is chelating ligands. So what is this first one is a monodentate ligands. The monodentate ligands. The monodentate ligands means the ligands contains only one group. The one group will be called as a monodentate ligands. Like for example, if you take the ammonia molecule will be called as monodentate ligand. Then if a compound will be having the water molecule will be called as the another ligand. Then we will be having a carbonyl group will be called as another A group is there. Then we will be having the chloride. Then we will get the bromide. So all these compounds will be called as a monodentate ligands. They will be called as a monodentate ligands. So suppose for example, what are the examples of a monodentate ligands? What are the examples of a monodentate ligands? So the first one is what is called as a cupro-ammonium sulfate. This compound is an example of what is called as a monodentate ligands. The monodentate ligands means this structure of cupro-ammonium the sulfate will be contains the same the four ligands, that is ammonia molecules. Hence it will be called as a monodentate the ligand. Example is cupro-ammonium sulfate. So if you read this structure already I have shown this one. CuNS3, this is CuNS3, and this is CuNS3, and this is CuNS3. So this is called as the example of what is called as a monodentate the ligand. The monodentate ligand, that is cupro-ammonium sulfate. Then we will be having the another compound. Suppose for example, if you take the best example is so K4FeCN6, potassium ferrocyanide. K4FeCN6 will be called as potassium ferrocyanide. So if I write this structure Fe plus 2, this is the first ligand, the cyanide, this is the second ligand, and this is the third ligand, and this is the fourth ligand, and this is the fifth ligand, and this is what is called as the last one is the sixth ligand of cyanide ion. So these are all the examples of what is called as a monodentate ligands. So that is the monodentate ligands means So those ligands contains only one group in the structure of the coordination compounds will be called as monodentate ligands. Suppose for example cuprammonium sulfate, potassium ferrocyanide, potassium ferricyanide, platinum hexamino compounds, then palladium hexamino compounds. All these compounds will be called as the monodentate ligands. Then what about the bidentate ligands? The second one is a bidentate ligands. So the bidentate ligands means you will be having a bidentate ligands. So this bidentate ligands means the ligands contains the complex compounds will be contains the two ligands. So that is called as that is bidentate ligands. So suppose for example CH2 NH2 and single bond CH2 NH2. So this is called as an example of what is called as a bidentate ligand. This is the example will be called as a bidentate ligand. So this ligand can contains that is two basic amino groups. So hence it will be called as a bidentate ligands. So in the same way, if you having the tridentate ligands, the tridentate ligands means it will be contains the three that is ligands. The three ligands will be present in the complex structure will be called as a tridentate ligands. So then the next is a polydentate ligands. The polydentate ligands means tridentate ligands. The example will be like this. So that is another one example. That's what is called as CH2 single bond CH2, and this is N, and this is N. This is CH2 COO minus, and this is CH2 COO minus. This is CH2 COO minus, and this is called as CH2 COO minus. So this is called as an example of a polydentate ligands. This is the example of what is called as a polydentate ligands. So these are polydentate ligands, that is more than the 4 or the 5, more than above the 4 the ligands are present in the coordination compounds. Those compounds will be called as a polydentate ligands. They will be called as a polydentate ligands. So these ligands, that is they can suppress each ligand can donate a pair of electrons. That is 2 electrons can suppress to what is called as central metal ions. Okay. The next we will be come across what is called as the nomenclature of the main postulates of what is called as these coordination compounds. The main postulates of coordination compounds is in the coordination compounds with metals allows the two types of linkages. So the postulate of what is called as coordination compounds is the any complex compounds they can allow the two types of valencies, that is a primary valency and a secondary valencies. The first one is a primary valency and a secondary valency in any of the complex compounds. Suppose if we having cuprammonium sulfate, so this cuprammonium sulfate will be having two types of valencies, that is the one is a primary valency and a secondary valencies. In the same way, potassium ferrocyanide, potassium ferricyanide, all these compounds will be having the two types of valencies, that is a primary valency and a secondary valencies. Then the second one is the primary valencies are normally the ionizable and are satisfied by negative ions. So the primary valencies are ionizable. The primary valencies are ionizable and they will be having the negative ions. They can satisfy that is a negative ions. Suppose for example, what is this second? The postulate is this one is so if we having the complex compound. So if we having a complex compound is CuNH3 the 4 times SO4. So this is called as this is a cuprammonium sulfate. This is a cuprammonium sulfate. So this compound will be decomposed into CuNH3 the 4 times. I will charge this plus 2 plus SO4 minus 2. So that is it is neutralized by what is called as a negative ion of a sulfate. This is a negative ion of a sulfate. So this is called as a positive ion and this is called as a negative ion. Sulfate ion will be called as a negative ion.